Hi everyone, in this video we are going to see how to calculate the area of a triangle when three sides have been provided. We are going to derive the formula of the area of a triangle using the three sides. Let's suppose we have a triangle ABC as you can see in the diagram, where the side length AB is denoted by lowercase c units, side length BC is denoted by lowercase a units, and side length AC is denoted by lowercase b units, and also the semi-perimeter of this triangle denoted by lowercase s, that will be equal to half of the sum of the three side lengths, that would be a plus b plus c over 2. And also the angle BAC is denoted by an uppercase A radian, angle ABC is denoted by uppercase B radian, and angle ACB is denoted by uppercase C radian. In a previous video, we have seen the half angle formula using the semi-perimeter and the side lengths, and the half angle formulae are like this. Sine of A over 2 is equal to square root of S minus B times S minus C over B times C, and similarly sine of B over 2 will be equal to square root of S minus C times S minus A over C times A, and sine of C over 2 will be equal to square root of S minus A times S minus B over A times B. And similarly the half angle formulae for the cosine ratio would be like this. Cosine of A over 2 will be equal to square root of S times S minus A over BC, and cosine of B over 2 will be equal to square root of S times S minus B over CA, and cosine of C over 2 will be equal to square root of S times S minus C over AB. In the first video for the area of triangle, we have seen that the area can be expressed as half times AB times sine of C. If we use the half angle formula for sine of C, then it will be half times AB times 2 times sine of C over 2 times cosine of C over 2. In place of sine of C, I have written 2 times sine of C over 2 times cosine of C over 2. Now here you can see this 2 here and this 2 here, they will cancel out each other. So we are going to be left with A times B times sine of C over 2. For sine of C over 2, I am going to use the highlighted value here, so that would be square root of S minus A times S minus B over AB times, we are going to use the highlighted value of cosine of C over 2, and that is actually square root of S times S minus C over AB. And now if you look at it carefully, you will notice that this is going to be equal to AB divided by, we have square root of AB 2 times in the denominator, and then in the numerator we are now going to be left with square root of S times S minus A times S minus B times S minus C. And from here you can see that this AB in the numerator will cancel out these two square root of AB's in the denominator. So then we are going to be left with square root of S times S minus A times S minus B times S minus C, and this formula is actually known as Heron's formula. I have created a separate video on Heron's formula where I have shown you how to derive this formula using pure geometry, and here we derive the formula using trigonometry also. And if you look at this formula, you will see that all it uses is the side length, all three side lengths of the triangle. S, the semi-perimeter, can be calculated if we know the three side lengths. S will be equal to half of the sum of the side lengths, that is the semi-perimeter, and A is the first side, B is the second side, and C is the third side. Those are the side lengths of the original triangle. So when all three side lengths have been provided, we can use this particular formula to calculate the area of a triangle. Now let's take an example. Let's suppose we have an example where the three side lengths of a triangle have been provided, and the side lengths are like this. The first one is 4 cm, second one is 6 cm, and the third one is 8 cm. Now for us to be able to use Heron's formula, we have to calculate the semi-perimeter. So let's calculate the semi-perimeter first. Semi-perimeter will be equal to half of the sum of the three sides, and that will be 4 plus 6 plus 8 over 2, that will be 18 over 2, which means that's 9 cm. So the semi-perimeter turns out to be 9 cm. Now let's use Heron's formula, and here I am going to plug in the values. So that looks like square root of 9 times 5 times 3 times 1. So that would be 3 times square root of 15. And if we convert that into decimal, it is going to look like 11.62 centimeter square, because it is the area of the triangle, so the unit has to be square unit, and in this case the unit is actually centimeter, so we have to write it as centimeter square or square centimeter. So we can see that the area of this triangle is equal to 11.62 square centimeter. Heron's formula is a very handy tool. Whenever we have to calculate the area of a triangle, we can easily use it if we know the side lengths. So make a note of it. I hope everything made sense. Thank you for watching. See you in the next video.